me again. Chapter 5, the last week of class. I'm going to, in this clip, talk about the special cases under the multiple cash flows. And I will focus on the top three, annuity, annuity due, and perpetuity. So I'm going to use the board to discuss annuity, or also called ordinary annuity, annuity due, and perpetuity. Okay, I'm going to do several things so that we can finish one table. The first one is about the timeline. Second one is how to identify it. I'm going to write down for each case 4 conditions for us to make the decisions that, oh, it's an annuity, oh, it's an annuity due, and it's perpetuity. Then, after we identify each model, we're going to wrap up the present value formula. And the last thing, I want to give you 2 reminders. In doing the calculation. So let's first look at ordinary annuity. By definition, it is a stream of n cash flows occurred at the end of each period. So if I'm talking about a 5-year project where a streamline for 5 years cash flows. So if I will receive $100 at the end of each year, then I'm going to write down 5 upward arrows. They are the same in $100. So I have one horizontal line to show us that they are equal, okay, until 100 at the end of year 5. How do we identify it's an ordinary annuity? Number 1, we'll have equal cash flows. What does the equal cash flow mean? Same dollar amount, same sign, all positive inflows of $100, okay, or all negative outflows of $100. Number 2, finite n cash flows. So there should be a number for the n, like 100, 300, 5. Number 3, each cash flow occurs at the end of each period. At the end of each period, at the end of the year, at the end of the month, at the end of the quarter. The last one, equal intervals between every 2 cash flows. So which means between these 2 cash flows that are close to each other, 1 year. Between these 2, another year. Between these 2, another year. So in here, again, we can say equal cash flows, finite n, and of each period, and equal time intervals between every two cash flows. Then it is an annuity. The present value on the class notes, PV of annuity equals C divided by R times, in the parentheses, 1 minus 1 over 1 plus R to the power of n. Which means in this calculation, you need 3 parameters in order to do the calculation. They are C, R, and N. That's ordinary annuity. How about annuity 2? If you read the class notes, it tells us we still have a stream of n equal cash flows, either inflow or outflow, but each cash flow occurs at the beginning of each period. So I still use 5 cash flows over 5 years as an example. Then you see that I have $100, $100 for 5 years. But at the beginning of the year, but for ordinary annuity, no, at the end of the year. Okay, so see the difference. Then how do we make the judgment? We compare with ordinary. Item number 1, same as annuity. Okay, equal cash flows. 2, again, same as annuity. Number 3, at the beginning of each period versus at the end of the period. That's different. Okay. Number 4, same as annuity. Then for present value calculation, with the same C, same R, and same N, the only difference is the occurrence of each cash flow. Then we'll see the relationship. The present value of annuity due equals 1 plus R times the present value of annuity. If we have the same C, R, and N.